All right, so in this video, we're going to talk about one way to deal with multicollinearity. So the problem here is that x1 and x2 are positively correlated by construction. In other words, when I created the data, I built in a correlation of 0.866 when I created this data over here. What we want to do is create a new variable, x1 prime, such that it's uncorrelated with x2. So if we take a look at this estimation, what we're going to do is say that x1 is equal to alpha plus gamma, another coefficient, times x2 plus some error term. So by construction in a regression, the error term is uncorrelated. It is orthogonal to x2. Okay? So it is not going to be correlated with these guys. And therefore, the error term is going to be the component of x1 that is not a function of x2. So that way we can use the error to get any additional explanatory power from x1. So this is the part of x1 that is explains the value of y that is not also explaining part of x2. So we want to create this uncorrelated section. Let's go ahead and do it, and I think that'll help generate your idea. First thing we're going to do is go ahead and create a copy. We're going to create a copy of this guy, and we're just going to move it to the end. And just leave it as called core x1, x2, parenthesis 2. Okay? So this becomes a graded tab as well. And the next thing we're going to do is go ahead in our data analysis, and we're going to run a regression. So our labels are checked here. So our y's are x1, and then our x's are in fact x2. Okay? And that's just this equation, right? This is the y and this is the x. All right, so we're going to create a new worksheet, and it's called residual t's, and we're going to check this little box that we want the residuals, in other words, the extra component, the error associated with it, to be output. So we'll just go ahead and click OK. So these are the residuals. So these are the errors associated with regressing x2 against x1. We got 50 of them, so now I want to use these guys to actually do the estimation. So I'm going to hold down my shift key, and that's going to highlight that whole column. I'm going to do a control C. That's going to copy everybody. And then I'm going to come over here to my x's, x1s, and I'm going to put in the residuals. Do a control V. So at that point, I've got all of my coefficients. Let me fix this little thing. I don't know where that came from, but I don't like it. So this becomes our new equation. You can see that standard errors dropped on our x2 because we've removed the multicollinearity. The coefficient is no longer supposed to be minus 0.57. It is supposed to reflect the uncorrelated component of x2. So we can also see, if we look at our core 1, our explanatory power was 56%. If we look at our second one, we've got basically the same correlation between the two. So our R squared remains about the same, and that's because we removed the component of x2 that was important. We removed the component of x1 that was important to x2. So our t-stats are still significant. And again, the interpretation of this coefficient becomes a little more difficult. But we've removed the multicollinearity associated with it, and you can see that we're basically uncorrelated. This is 0, right? So we've gotten an uncorrelated variable, so x1 prime, right? The residual, let me go ahead and change that to a prime. The residual of x1 the error associated in regressing x2 against x1 is then uncorrelated. You can see that it has come up to, in fact, be uncorrelated. And that removes the collinearity from the regression and then gives us the coefficients estimated a little bit more efficiently. All right, so that's the only thing I wanted to go over. I know the removing the correlations is a little bit more complex than maybe you guys are used to, but I want to give you a little idea of what other possibilities are out there. All right, well, thank you very much. This is just the basic aspects of running regressions, and you can then look at how well each one of the estimates actually did. All right, well, thank you very much, and goodbye.